Imagine you're in a pitch black room. You can't see a thing, but you know there's a light switch somewhere. You fumble around, feeling the walls, until suddenly click. The lights come on, and the room is revealed. Simple, right? But here's the million-dollar question. Did you create the room by observing it? Or was it there all along? Now I know what you're thinking. Sebastian, that's ridiculous. Of course the room was there all along. And in our everyday world, you'd be right. But dive down into the realm of quantum physics, and suddenly the seemingly absurd idea starts to make a whole lot of sense. Let me take you on a little journey. Back in the early 20th century, physicists were scratching their heads over something called the double slit experiment. It goes something like this. You've got a wall with two slits in it. You fire particles, let's say electrons, at the wall. Behind the wall is a detector screen. If electrons were just ordinary particles, like tiny bullets, you'd expect to see two bands on the detector, right? One band for each slit. But that's not what happens. Instead, you get this stripy pattern, like waves interfering with each other. It's as if each electron is going through both slits at once and interfering with itself. Wild, right? But here's where it gets really freaky. When physicists tried to observe which slit each electron was going through, the interference pattern disappeared. Just by watching, they changed the behavior of the electrons from waves to particles. Let that sink in for a moment. The mere act of observing changed the fundamental behavior of reality. This is the observer effect, and it's not just some quirky feature of a lab experiment. It's a fundamental aspect of how our universe works. Reality, at its most basic level, doesn't seem to be real until it's observed. It's like the universe is a cosmic choose-your-own-adventure book. And every time you make an observation, you're turning to a new page, collapsing all the other possibilities into one concrete reality. But here's the kicker. It's not just about conscious observation. Any interaction that could potentially give away information about a quantum system can cause this collapse. Your eye's a measuring device, even a stray photon bouncing off a particle, they're all constantly collapsing wave functions, turning the fuzzy, all possibilities at once quantum world into the concrete reality we experience. Now, I know this sounds crazy. Trust me, it sounded crazy to me too when I first encountered it. But this isn't just some fringe theory. It's a core feature of quantum mechanics, one of the most successful scientific theories we've ever developed. Every smartphone, every computer, every MRI machine, they all work because this bizarre quantum behavior is real. So what does this mean for us in our everyday lives? Well, in a very real sense, you're shaping reality just by existing. Every time you look at something, every time you interact with the world in any way, you're collapsing wave functions, turning quantum possibilities into concrete reality. You're not just passively observing the universe. You're actively participating in creating it. The universe isn't just out there. It's a co-creation between you and everything around you. So the next time you look up at the stars, or into the eyes of someone you love, or even just glance around the room you're in right now, remember you're not just seeing reality. You're helping to create it. In a universe where the act of observation shapes reality, every moment is an act of creation. And you, my friend, are the observer, the creator, the quantum magician turning possibility into reality with every breath, every blink, every beat of your heart. Pretty mind-bending, isn't it? And we're just getting started. There's so much more to explore about the nature of reality, consciousness, and our place in this bizarre quantum universe. But that's a story for another time. Until then, keep observing, keep questioning, and remember you're shaping reality right now. This is Sebastian, and you've been listening to the Quantum Observer.